In the tutorial about linear probability model and its problems, we discussed how the application of OLS is not appropriate when we have a binary, categorical or qualitative dependent variable. In such cases, OLS or LPM suffer from some serious problems. Firstly, the probability from linear probability model or LPM might exceed the limits of 0 and 1. Negative or greater than 1 probability does not make sense. Secondly, the residuals from the model are heteroscedastic and do not have a constant variance. This violates one of the core assumptions of OLS and makes the estimates inefficient and tests of significance are no longer valid. Finally, LPM assumes a linear relationship between independent variables and the binary dependent variable. As discussed in the LPM tutorial, this is not realistic because the change in probability should be slow or small at extreme values of independent variables. That is, with a small change in independent variables, the change in probability should be different at different levels of those independent variables. Let us go to our example of car ownership, which is stated as shown here. To solve the problems of LPM, we need to represent the probability of owning a car with the help of a nonlinear function that fulfills two criteria. The function must not exceed the limits of 0 and 1. That is, the probability of owning a car should always be between these limits. The relationship between the probability of owning a car and income must be nonlinear in a way that the changes in probability are smaller as we approach extreme values of income. That is, as the income keeps falling, the changes in probability must grow smaller as it approaches a probability of 0. Similarly, as the income keeps increasing, changes in probability must be smaller and smaller as probability approaches 1. These two requirements are fulfilled by the sigmoid or logistic function and the normal cumulative distribution function. These nonlinear functions form the basis of the Logit and Probit models. The logistic function, also known as the sigmoid function, is used in the Logit model and the normal CDF is used in the Probit model. The general shape of these functions is shown here. As we can see from the shape, these functions do not exceed the limits of 0 and 1. As they approach the probability limits of 0 and 1, they become flatter and the changes in probability grow smaller and smaller. That is, as we approach extreme values of variable on the x-axis, the changes in probability are small. In the middle part of the diagram, we can see that the probability changes much faster as compared to the tails or extremes. Therefore, both these functions fulfill the requirements that we stated earlier. Now, let us take a look at these functions. Both the logistic or sigmoid function and the normal CDF are shown here. The probability of success, Pi, depends on the value of Zi. In turn, Zi is a function of the independent variables. In our example of car ownership model, this Zi is a function of income or y. Moreover, Z is a linear function of income y as shown here with the parameters beta1 and beta2. However, the probability of success or probability of owning a car is a nonlinear function of Z. In the Logit model, the sigmoid function projects the value of Z between 0 and 1 to obtain the probability of owning a car. Similarly, in the Probit model, the normal CDF does the same thing to obtain the probability of success. To determine Z and then the probability, we need to know the value of parameters beta1 and beta2. We can estimate these parameters using the maximum likelihood approach. We use the sigmoid or logistic function to construct the likelihood function in the Logit model and estimate the parameters. Similarly, we use the normal CDF in the case of Probit model to construct the likelihood function and estimate the parameters. We will discuss how to derive the likelihood function in the next tutorial. The most basic difference between the Logit and Probit models is their link functions. That is, Logit model uses the sigmoid function whereas the Probit model uses the normal CDF. The sigmoid function and the Logit model are relatively simpler whereas the calculations from the Probit model can get very complex. That is why the Logit model has been favored traditionally and extensive literature is available on it. However, with the advancements in software, estimating the Probit model is now as easy as the Logit model. Another difference between the two models is in their interpretation. The coefficients in a Logit model are interpreted in terms of log odds. A 1-unit change in a predictor variable changes the log odds by the amount equal to the coefficient. Probit model coefficients represent the change in the z-score for a 1-unit change in the predictor. Both these interpretations make little economic sense, therefore, we usually estimate the marginal effects after Logit and Probit models and interpret those. We will discuss the marginal effects and their interpretation in the upcoming tutorials. The Logit and Probit models give similar results in most cases. For example, let us say that we want to predict whether an individual owns a car or not based on a 0.5 probability cutoff. That is, if probability is less than 0.5, we predict that the individual does not own a car. On the other hand, if probability is equal to or greater than 0.5, we predict that the individual owns a car. In most cases, the Logit and Probit models will make the same predictions about whether an individual owns a car or not. In some rare cases, we might see differences between their predictions. If we look at the shapes of both the functions, we can see that the sigmoid function has fatter or thicker tails as compared to the normal CDF. That is, normal CDF approaches the limits of 0 and 1 a lot faster. This means that if the dataset has a lot of extreme values or outliers, then the Logit model might perform a little better. This is because the underlying sigmoid function has thicker tails and might be able to handle outliers better as compared to normal CDF and Probit model. Thank you for watching, and I will see you in the next tutorial.